In this tutorial, I'm going to go over number 19 on our Unit 9 exam review. So number 19 is a three-part question. It will be a free response question on your exam as well. So we know that the diameter of a circle has endpoints at -11, 14, and 0.52. And the three things that we want to do is find the center, find the radius, and find or write the equation for the circle. So the two things that we need in order to write the equation are the center and the radius. And since the only thing that we know are 2 points that are on the circle, we want to go ahead and use our distance and our midpoint formulas in order to find the center and the radius. So if I am finding my center, we are going to use the midpoint formula because I know that if I have a circle with endpoints of the diameter, we know that the diameter goes through the center of the circle and that the center is the midpoint between the endpoints of the diameter. So the 2 points again are -11 and 14 and 5, 2. And our midpoint formula, which I'll write off to the side here, is just our x coordinates divided by 2. And our y coordinates added together and divided by 2. So with our 2 points, we always have an x and a y coordinate in each one. So we need to add up our x's and our y's. So my x1 and x2 value are -11 and 5. We'll divide by 2. And then y1 plus y2 is 14 plus 2. Divided by 2. If we go ahead and simplify this, we have to add the numerators and then divide by 2. So -11 plus 5 is -6. 14 plus 2 is 16 divided by 2. -6 divided by 2 is -3. 16 divided by 2 is 8. So our center point of this circle is -3, 8. Part B is finding the radius. In general terms, a radius is just the distance from the center to a point on the circle. So we can use our distance formula to find the length of the radius. So the thing to keep in mind with finding the length of the radius is that we want to make sure that one of the points is the center. So we only want the distance from the center to a point on the circle. So one of them has to be -3, 8. And you can choose between -11 and 14 or 5, 2. So I tend to go with the numbers that are smaller. And I try to pick the one where both of those coordinates are positive as well. All right, so 5, 2 is going to be the one that I choose. If you want to use negative 11, 14, that's okay. You'll still get the same answer. So as always, we need to label our x1, y1, and x2, y2 coordinates, because those are going to be the 4 numbers that we use in our distance formula. So the distance formula I'll write in red here. It is the x coordinates subtracted from each other and squared. And it's the same for the y coordinates. So my first set of parentheses is x2 minus x1, so 5 minus negative 3. And then y2 minus y1 is 2 minus 8. So we always simplify inside of our parentheses first. 5 minus negative 3 turns into 5 plus 3, which is 8. And 2 minus 8 is a negative 6. Next, we can go ahead and square that 8 and negative 6. 8 squared is 64. And then if I have a negative number that is being squared, it is positive. So negative 6 squared is a positive 36. Then we can go ahead and add 64 and 36, which is 100. We can take the square root of 100, which is a perfect square, and we get 10. So the distance between the center and a point on the circle is 10, which means that our radius is also 10. And then our last part is just putting these two pieces together to write our equation. So off to the side here, I'm going to write our equation of the circle. And as always, we need the center, which is negative 3/8, which is what we found in part A. And we need the radius, which we found in part B, which is a length of 10. So we always go opposite signs for the h and the k values. So if I have a negative 3, we're going to have x plus 3 squared. We have a positive 8, so we will have y minus 8. And then we have a radius of 10, but we need r squared in our equation, which is 10 squared, or 100. So that is question 19, which is finding the center, the radius, and writing the equation of the circle.